Assalamu alaikum. Bismillahirrahmanirrahim. Today we will discuss about periodic trends. Periodic trends are simply defined as the behavior of certain properties alongside a period or alongside a group from top to bottom in a periodic table are called periodic trends. These include ionization energy, electron affinity, atomic radius, metallicity, and bonding properties, etc. This figure shows the periodic behavior of noble gases and their atomic number and ionization energy trend, which decrease down the group. Review. So the elements of periodic table are placed into rows by the number of energy levels they have and groups by the number of valence electrons they have. Blocks by what kind of sublevels they are. So in periodic table there are two main things, periods and groups, and periods are defined by the number of energy levels and groups are defined by the number of valence electrons. And the periodic table on a whole is divided into certain blocks like S block, P block, T block. So if outer electrons are placed in S orbital, then the block all elements, those who have outer electrons in s orbital, then they are called as s block elements. Atoms can gain or lose electrons, and metallic atoms lose electron and form cations, and non-metallic atoms have the property to gain electron and form anions, and in this way they are called reduced. Metallicity or metallic behavior of elements along the periodic table. Towards the left side, the metallic character increases, and group 1A elements are most metallic in nature because they can easily lose electrons. Towards the right side, in periodic table, in a period when we go from left to right, the metallicity decreases, and this depends upon the less affinity of atoms toward to lose electrons. Therefore, from left to right in a period, the atoms tends to gain electron, not lose electrons. Therefore, toward the right side, mostly non-metals are present, like carbon, and toward the left side of periodic table, mostly metals are present, like sodium. And from top to bottom, metallic character increases. This is because from top to bottom, the shell number is increased and atoms lose electrons easily. You can take example that if a person have more bulkier size or have more things, then if he lose one thing from a million things, it is easy for him to lose. And if a person have only two or three things, then it is difficult to gain or to lose that thing. So therefore, sodium its size is smaller, but it loses electron easily than its right side element. But when we go from sodium to the downward element, then we can conclude that this element loses electron easily because it have one more shell and its size is bigger. Therefore, it is easy to extract electron from here. Therefore, metallic character decrease from left to right in a periodic table and increase from top to bottom in a group. So what is atomic radius? Here the question arises, and how is the ionic radius related to the atomic radius? And what is the trend concerning atomic radius? What is ionization energy and what trend is associated with? What is electronegativity and what trend is associated with it? So firstly we consider atomic radius. Atomic radius is the distance from center of atom to outer electrons. It decreases across a period and increases down a group. This is because number of protons increase from left to right in a periodic table, and therefore these protons attract electrons and the size get shrinked, and number of shells increase down a group. Therefore when we move from top to bottom, the size increases and the protons hold or capturing or attracting power of electrons decrease from top to bottom. That's why size increase. For example, lithium have bigger size than beryllium because lithium and beryllium have same shell, but number of electrons in lithium are less and number of electrons in the shell are more. Here lithium have 3 protons and beryllium have 4 protons. Therefore, the proton size is bigger and increase of electrons do not affect so much, but increase of proton affects so much because their size is bulkier and they attract more electrons, therefore they shrink the size. Here 5 protons and they shrink more, and carbon have 6 protons, therefore the size is more shrinked. Similarly neon have 10 protons and therefore its size is shrinked. Increasing atomic radius means greater attraction for electrons. And atomic radius increase from top to bottom in a group. For example, fluorine have smaller size in halogens, then chlorine, then bromine, then iodine, then styrene. Because chlorine have two shells, then fluorine have two shells, then chlorine have three shells, four shells, five shells, and six shells. Therefore, number of shells are increased, and the distance from the nucleus to the outer electron increase, and in this way the size is increased. Increasing the number of energy levels means a larger atom. Therefore, along a periodic table, we can say downward in a group atomic radius increases and upward in a group atomic radius decreases. And if we move from left to right, radius decreases, and if we move from right to left, then radius increases. So sodium and carbon are in the same period, and sodium is on the left side and carbon is the right side. Therefore carbon size is you can say lithium and carbon are in the same period. Therefore carbon size is smaller than lithium because carbon have more protons than lithium and they are in the same period. Therefore their size of carbon is more. Ionic radius cations are smaller than their atoms. This is why, because if we move electron from an atom, then the remaining electrons are more strongly held together or held toward the nucleus because of the strong positive attracting effect of protons. Anions are larger than their atoms. You have to remember that lithium and lithium plus size is smaller than lithium because Li plus in lithium there is one electron in outer shell. When that electron is removed, then shell is also removed. Therefore, the remaining same three protons attract two electrons more strongly and shrink the atom. In fluorine, if it gain one electron, then one shell number is increased, and distance from nucleus to the outer electron is also increased. Increase of energy level increase its radius. Therefore, cations have smaller size than their parent atoms and anions have larger size than their parent atoms. We have discussed atomic radius. Now we go toward the ionization energy. Energy required to remove electron. You can say remove one electron. We can remove more than one electron, but generally we use remove one electron from an atom. For example, this is an atom and it is one electron. Say it is hydrogen. So if we place the energy here, then it goes toward this direction, and if we use the energy, and then this electron is removed. So remove of this electron is require some energy, and this energy is provided by the external source, and this external source expel the electron. So it increases across a period because the ionization energy depends upon the atomic radius. Atomic radius decrease from left to right across a period. Therefore, it is more difficult to expel an electron from the nucleus. It decreases down a group because size increase from left to right and distance between nucleus and outer electron is increased, and outer electrons are less tightly bound to the outer electron of down atoms in a group. Therefore, less energy is required to remove them, and ionization energy decrease down a group. Ionization energy can be used to predict the formation of ions. If an element requires very little ionization energy, it is more likely to form a cation. And anions are formed when the ionization energy is high. Noble gases form no ions. You now the metallic behavior is also related with ionization energy. If first group elements have low ionization energy, therefore less energy is required to remove their electrons, and they remove their electron easily and they are more metallic. Halogens have 7 electrons in their outer shell, therefore, and their atomic radius is smaller than first group elements. Therefore, higher energy is required to remove electrons, but less energy is, gained, is required to gain electron. And thus, in this way, they form anions easily, and their metallic character is not good enough. Electronegativity. So this is another periodic property and tendency of an atom to attract electrons in a chemical bond. It increases across a period and decreases down a group. It excludes noble gases. It has same trend like ionization energy. You have to remember some ionization energy electronegativity values. Hydrogen have 2.1, and here boron has 2.0. Carbon in second group here, lithium have 1, beryllium have 1.5, boron have 2, carbon 2.5, nitrogen 3, oxygen 3.5, and fluorine have 4. It increases across a period and decreases down a group. This is because when we move from left to right in a periodic table, the atomic radius decreases. For example, beryllium atomic radius is less than lithium because it have 4 protons and lithium have 3 protons. Therefore, it is more attractive toward electron because it have more protons, and its electronegativity is more than lithium. Similarly, in case of nitrogen and oxygen and fluorine, nitrogen have 7 protons, oxygen have 8 protons, and fluorine have 9 protons, and therefore its energy requirement for incoming electron is more. In the other factor is fluorine have 7 electrons in its outermost shell. Therefore, it is highly affinity toward electron, and its demand for electron is much higher than oxygen and then nitrogen, because oxygen requires 2 electrons and nitrogen requires 3 electrons to fill the shell. Fluorine requires only 1 electron and its size is much smaller than all these and it have more number of protons. Therefore, its electronegativity is highest in the periodic table, and it is the highest electronegativity and very reactive element in the periodic table. So fluorine, chlorine and bromine, iodine, acetylene, you can see the electronegativity decreased down the group because number of shells increase, atomic radius increase, and affinity for electron also increase. The question is, why noble gases have no electronegativity values? Because noble gases have filled outer shells and there is no affinity and no attraction for electrons. So the periodic trends, in conclusion, we can say ionization energy decrease across a period, increase across a group. Sorry, ionization energy and electron affinity increase across a period because atomic radius decrease across a period. Ionization energy and electron affinity increase across a group from down to upward direction. This is because from down to upward direction size decrease, and from upward to downward direction top to bottom in a group the ionization energy decrease, electron affinity decrease, and electronegativity decrease. Only one factor increase from top to bottom, that is atomic radius. And from left to right, electron affinity increase, electronegativity increase, and atomic radius decrease. So from left to right, metallic character also decrease, like atomic radius, and non-metallic character increase from left to right in a periodic table. From right to left, atomic radius increase. So in general, you can say atomic radius and all other electron gain or loss properties are inversely proportional to each other. And atomic radius, you can remember, from left to right, proton increase, therefore atomic radius decrease. If atomic radius decrease, then the inversely proportional electron affinity, ionization energy, and electronegativity also decrease and increase inversely proportional. And from top to bottom, atomic radius increase, therefore the inversely proportional electron affinity, ionization energy, and electronegativity decrease. So from left to right, as the number of protons are increased, therefore metallic character is also decreased. This is because if there are more number of protons, then it is difficult to abstract an electron from atom. Thank you very much. So for more information, you can contact at our this number.